Welcome to Week 10, Part 2, Polynomial Functions. So to start, we review on some facts. So if we have a polynomial functions, f of x equal ax to the power of n, and a is the leading coefficient, and n is the high degree. So we have two types of the polynomial functions. The first one is you have the even n. It means your degree is n is 2, 4, 6, 8, 10. And we have odd n is n equal 3, 5, 7, 9. And the most common one is x squared, right? It's n equal 2 and x to the power of 3, x cubed, n equal 3. So they will follow the characteristic when we graph them. If we have the even n, you see left n and right n always in the same directions. So in this case, we see that if f of x equal x squared, both n, left n, and right n of the graph go direct up, like upward, go upward, right? And if we have the negative x squared, it will go down, right? So we know that for the even n, we have left n and right n will be same direction. Compared to n odd, like n equal 3, on the right hand side, we will have the left n and the right n always in opposite directions. When the left n go down, the right n go up. When the left n go up, the right n go down. So making sure that we know this is 1, 2, 3, 4 different graphs. Okay, and what does that mean? When we have the left n and right n of the even n, is we have the positive leading coefficients. It means a greater than 0. And if we have the graph number 2 and number 4, we have the negative. We see that here. A here is -1. A in this case is -1 as well. And a in this case is equal 1. So 1 greater than 0. -1 less than 0. This is a less than 0. Less than 0. In this case, a equal 1 and is greater than 0. So we just have to remember that if we have the right n, right, up, right and up, it means we have a positive. Because when right and up, for the even n, the left n have the same direction, right? So it's go up as well. And for the odd n equal 3 in this case, the left n will be different directions, opposite directions from the right n, right? So left n and right n opposite directions. One go up, one go down. same directions. If it's up, it's go up. It's go down, it will be go down. So by looking at that, we know we memorize it easier, right? Right up, we say right and up, right? It will be a positive. If right and down, what happened is a negative. So like that, go down. That easy to memorize one, and then we think about another one when we know the fact that for the even end degree, we'll have the same directions for left end and right end. If it's odd degree, we have left end and right end is in opposite directions. Alright. So when we look at a graph, how can we know what is the functions of that graph, represent that graph? So first, we have to look at the root of the graph, right? So in this case, in this example, I have 3 roots. I can see because one is touch the x-axis, one is cross, another one is cross as well, but is wiggle. That's how we find the root, right? But what does that mean? When you see the cross, a straight line cross a point, like in the yellow area, it represents multiplicity of 1. For that, zero factor. So what is the zero factor? So this called a zero factor because if you set each of that factor equals 0, you solve for x, you have root, right? That's the zero factor of f of x. So first we find all the roots. So we know that here we have x equal minus 2. That the root x equal minus 1, x equal 1. Now, then we find the zero factor. How we find the zero factor? The zero factor, we see that we have some x plus or minus some number that will be equal 0. So we have to have somehow make the right hand side is equal 0. So I have x equal negative 2, so I put 2 both sides. So I have x plus 2 equal 0. This one cancel out. So x plus 2 is one of my zero factor and is the purple one, right? Now continue with the yellow area. So we have x plus 1 both sides. So that my right hand side will be 0. My left hand side is x plus 1. So we have x plus 1 factor. Okay, so for x equal 1, I subtract 1 both sides, so that my right hand side will be 0. So x minus 1 is another factor. Okay, so we're done with the first step. The second step, we determine the multiplicity of each zero factor by looking at how it crosses the x-axis. So for yellow area, we have one line straight go across x-axis, and here is the x-axis. Okay, so when you see like the cross like that, it's a multiplicity of 1. It means it doesn't have anything right here. It is 1. So it means x plus 1 to the power of 1. Okay, And if we say something to the power of 1, we'd rather not writing that, right? So it's just like x plus 1. Then we look at the purple area. It touch, right? The graph go touch -2 and then bounce back. So what does that mean? It's the multiplicity of even number, and usually it will be 2. So we write down x plus 2, that multiplicity of 2, right? And also we have right here is a wiggle for the pink, light pink area, that the multiplicity of odd number. So commonly it will be 3. We will say x minus 1 to the power of 3. And that's how we got the whole function's f of x. But that's not done yet, right? So now we determine the multiplicity of each zero factor. Now we check the left and right end to find n is odd or even. We don't know what is n, right? We don't know n is even or odd. So we see that, oh, left end is go up and right end also go up. What does that mean? It means n is even. We know n is even because the left end and the right end is both go up, right? Same direction. That n even. So we have n even. Then we check for the number of the multiplicity. We have 1 here, 2 for factor x plus 2, and 3 for factor x minus 1. So we see that if we plot 1 plus 2 plus 3, that equals 6, and it's even. That even number. So it may be 6 is the minimum, right? But also, because we don't know for touching, we can have maybe x plus 2 to the power of 4, maybe, or x plus 2 to the power of 6, maybe, right? So we don't know n yet, but we know n is even. Or this one, x minus 1 to the power of 5, maybe. So what is the next one we have to do is check if the leading coefficient a is plus or minus, and also we can check the y-intercept if it's different from 0, 0. So we see that we have the y-intercept at -4. Y-intercept at -4. So just a reminder, y-intercept is when x equals 0, and then the graph cross y-axis at y-intercept. In this case, we have 0, -4. That's the point right here. Alright, now we know that if both left end and right end is go up, it means a positive, right? The lead coefficient a is positive. So we check that f of x that equal x plus 1 to multiplicity of 1, then multiply x plus 2 and the multiplicity of 2, so we squared. Then we have x minus 1, the multiplicity of 3, And then we check that the coefficient A, leading coefficient, will be right here at that position. And we know that positive. And N even. Okay, now we check for the y-intercept. How we check it? So we take the number here, multiply with the number here. So it will be 1 times 2 times -1. And also, we have to distribute the multiplicity outside to that number as well. So this one will be equal to square is 4, times 1 is 4, -1 cube is -1, times 4 is -4. So we see that when we're checking, we have that y-intercept equal -4. And we said that f of x is, now we can have our final answer at f of x equal x plus 1 times x plus 2 squared times x minus 1 cube. Let's practice on some questions. So now we have f of x with the graph like that, right? So we find the root. The root is x equal -5, x equal -4 here, x equal -1, x equal 1, and x equal 2. That's all our root. Then we find the zero factor. So this one will be x plus 5 equals 0, x plus 4 equals 0, x plus 1 equals 0, x minus 1 equals 0, x minus 2 equals 0. And now we find the multiplicity. So for the first root, we have a straight cross, so it will be multiplicity of 1. Okay, multiplicity of 1. For the second one, it's the same thing, right? It's cross, so multiplicity of 1. This one also the same, so they all have the multiplicity of 1. Now we check if n is odd or even. So left n is go up, right n is go down. And if right go down, it means a negative. So n is odd and a is negative. Then we check for the y-intercept. This one should be here, 0, -40. Now we rewrite f of x. So we have f of x equal x plus 5 times x plus 4 times x plus 1 times x plus minus 1 times x minus 2. Okay, and we count 1, 2, 3, 4, 5. So n equals 5 in this case. We said that a is negative 0, right? But let's check it if we forgot a is negative and where the a positions right here in front of the higher degree. So let's check the y-intercept first. So we have 5 to the power of 1 multiply 4 to the power of 1 multiply 1 to the power of 1 multiply negative 1 multiply negative 2. And that equal 5 times 4, 20, times negative 1, negative 20, times negative 2 is 40. But the thing is, our y-intercept is negative 40, not 40. That's when we have to go back and check for a, right? And in this case, we already check it, so a is negative. We just put the negative in the front because the y-intercept only need the negative, one negative. So we put everything with the negative in the front right here. It could be negative 40. So a in this case is negative 1. Now we can write down the final answer. Negative x plus 5, x plus 4, x plus 1, x minus 1, x minus 2. Then we're done. Let's look at that questions again and see if we don't have the negative, if we forgot it. You see that our y-intercept will be 40 instead of negative 40 in this case. And also, right here, the right end is down, so a is negative. On another side, because we don't have this one, a equal 1 is positive, so the right end is go up. So be careful to check the lead coefficient a every time we're working on a problem. And in this case, a is negative 1. Okay, so for next questions, first one we find root. So we have x equal negative 4. Then we have x equal negative 2. Then we have x equal 0. Now we find the zero factor. For the zero factor, this one will be x plus 4 equals 0. X plus 2 equals 0. And the last one, we already in that format, x equals 0. So for the zero factor, we want move everything to the left hand side and set it equal 0. Make the right hand side equal 0. Okay, now we find the multiplicity by looking at the graph. For the first root is straight cross, so multiplicity of 1. For the second one is touch and bow back, so it will be multiplicity of 2. And then the last one is cross, so multiplicity of 1. Now we check for n, we have left n down, the same directions at right n, so n is even. Now we check for a. The same directions but both go down is mean a negative. So a less than 0. In this case, y-intercept equals 0, so we could not determine if it work or not. But we have to remember a is negative here. So now we can rewrite f of x. F of x equal x plus 4 multiplicity of 1, and then x plus 2 square multiplicity of 2 times x to the power of 1. And remember a is negative, so we need the negative side here. So we'll have negative x plus 4 x plus 2 square times x. Okay, so in this case, see that right here a equal negative 1. That's our problem. And here, if we forgot that a is negative, we put a equal 1. It's positive. Both left and right end is up, so a positive. Both left and right end is down, a is negative. And also we're checking for n. We said that it's the same directions for left and right end, so it have to be even. So let's count 1 plus 2 plus 1 here. So 1 plus 2 is 3 plus 1 is 4, and 4 is even. So for this question, we do the same. We find root here, here, and here. So we can write down x equals 0, x equal 1, so x minus 1 is a factor, and we have x equal 3, so x minus 3 is another factor, 0 factor. Then we find the multiplicity. This one touch and bow back, so x squared. This one touch and bow back as well, so another square. This one goes straight across, so it's to the power of 1. Now left end and right end is opposite directions, it means n odd. The right end up, so a positive. So this is what's done, and also with the power of 1, we can just delete it. So similar for these questions, we find the root first. X equal negative 3, x equal negative 1, x equal 2, x equal 3. Now 0 factor. X plus 3 for the first one, Next one, x plus 1. We have x minus 2, x minus 3, x plus 3, x plus 1, x minus 2, x minus 3. Now we do find the multiplicity. So the first one is cross, so that's 1. The second one cross, so 1 as well. They are cross, right? So all 1. Now we check the end, the left end and right end. Both up, same directions, and even. And because the right end up, so A is positive. So let's check on this one, and equal 1 plus 1 plus 1 plus 1. And that 4, and that even. Then we know that it somehow is above 15. We could not see in this graph well enough, but we can check it by finding y-intercept. So we have 3 to the power of 1 times 1 to the power of 1 times negative 2 to the power of 1 times negative 3 to the power of 1. So we have 3 times 1 is 3, times negative 2 is negative 6, times negative 3 is 18. And that kind of match, because we have 1, 2, 3, 4, right? So this one will be 1, 2, 3, so it's 15, and 3 will be 18 right here. So that match. And then we're good to go. Thank you for participating in this quick practice questions. See you next time.